This video content produced by quantumblogger.com. Part 2 of the ion trapping video discusses its technology, challenges, and real-world applications. In Part 1, we explained what ion trapping is and its advantages. The second part discusses other highlights of ion trapping, including real-world applications and challenges, as well as how humans can benefit from it. Real-world applications. Quantum simulation. Quantum simulation is the use of quantum systems to simulate other quantum systems. Quantum chemistry. It has the potential to provide new insights into complex quantum systems that cannot be simulated by classical computers. Material science. Ion trapping technology can be used to simulate the behavior of complex molecules, such as those found in chemistry and materials science. This can be used to study the properties of newly developed materials, design new drugs, and understand chemical reactions at the quantum level. Quantum cryptography. Quantum cryptography is the use of quantum mechanics to secure communication. It allows the creation of unbreakable cryptographic keys, which can be used to encrypt messages. Ion trapping technology can be applied to create a quantum key distribution (QKD) system, which uses trapped ions to generate and distribute cryptographic keys. This can be used to protect sensitive information, such as financial transactions and government communications. Ion trapping technology can also be used for quantum computing applications such as optimization, machine learning and artificial intelligence. Ion trap quantum computing can be used to solve optimization problems that are too complex for classical computers to solve efficiently. Additionally, ion trap systems can be used in quantum machine learning and artificial intelligence for complex computations like speech and image recognition. In summary, ion trapping technology has a wide range of potential real-world applications, including quantum simulation, quantum cryptography, optimization, machine learning and AI. These applications have the potential to provide enlightening insights and solutions to complex problems in various fields such as chemistry, materials science, communication, finance and more. Challenges and limitations. Precise control of the trap environment. Ion trapping technology requires precise control of the trap environment in order to minimize decoherence, the process by which a quantum system loses its coherence. This requires sophisticated control systems and a high level of technical expertise. Scaling up the technology. Scaling up ion trapping technology to create larger systems with more qubits is a significant challenge. This requires the development of new techniques for trapping and manipulating large numbers of ions, as well as the development of new control systems. High cost. Building an ion trap system can be expensive, as it requires off-the-shelf components such as an ion trap chamber, lasers, and other specialized equipment. Complexity. Ion trap systems are delicate and require a high level of maintenance and care. Building and operating an ion trap system can be complex and requires a high level of technical expertise. Fragility. They can be affected by vibrations, temperature changes, and other environmental factors. Limited number of qubits. Ion trap systems currently have only a small number of qubits. It will be necessary to develop new techniques for trapping and manipulating large numbers of ions in order to scale up to larger systems. While ion trapping technology has many advantages, it also faces some challenges such as precise control of the trap environment, scaling up the technology, high costs, complexity, fragility, and a limited number of qubits. The research in ion trapping technology is ongoing despite these challenges, and scientists are trying to overcome these obstacles to make it more viable for quantum computing. This video concludes with a brief overview of the current industry players. As we demonstrated, ion trapping is a promising method of quantum computing that involves using electromagnetic fields to trap individual ions and control their quantum states. This technology has a wide range of potential applications, from cryptography and drug discovery to optimization and machine learning. In this segment, we will explore the major players in the ion trapping industry and their systems and capabilities for video content. One of the major players in the ion trapping industry is IonQ. IonQ Forte, which is an ion trapping system available since 2022, is the latest evolution in software configurable quantum computers. Configuration of gates and qubits can be customized according to user needs, resulting in a flexible and dynamic system. They have developed a trapped ion quantum computer that uses a unique 2D array of ions to perform quantum computations. The system is capable of performing a wide range of quantum algorithms and has been used for applications such as quantum simulation, optimization and machine learning. As well as video content processing, IonQ quantum system can also perform facial recognition and video compression. Another major player in the ion trapping industry is Honeywell. Error rates at the leading edge of industry capabilities with high fidelity and high qubit count. They have developed a trapped ion quantum computer that uses a linear chain of ions to perform quantum computations. The system is capable of performing a wide range of quantum algorithms and has been used for applications such as quantum simulation, cryptography, and optimization. Honeywell's system is also capable of video content processing, and it is capable of detecting, tracking and recognizing objects in real-time video streams. A third player in the ion trapping industry is Oxford Ionics. They have developed a trapped ion quantum computer that uses a 2D array of ions to perform quantum computations. The system is capable of performing a wide range of quantum algorithms and has been used for applications such as quantum simulation, optimization and machine learning. The Oxford Ionics system is mostly an experimental research group, testing and developing ideas in quantum computing using trapped ions manipulated by microwaves and lasers. In conclusion of this video, the ion trapping industry is rapidly advancing and has a wide range of potential applications. As of 2023, companies like IonQ, Honeywell, Quantinuum, Alpine Quantum Technologies, Oxford Ionics, LA Qtron are leading the way in the development of trapped ion quantum computers, and some of these systems have capabilities for video content processing. These capabilities include video compression, facial recognition, object detection, and video enhancement. As the industry continues to grow, we can expect to see even more advanced systems and capabilities for various quantum computation projects, AI and video content processing in the future. Thanks for watching.